Oh my goodness. I feel like we're not beating a dead horse anymore. We are beating the fossilized dead horse that has already returned to the earth and has started sprouting flowers. But then we dug up those flowers to find the old carcass of the horse so that we can continue to beat it. Sounds very suggestive. But anyway, because we are still learning more things about the 12 volt 2x6 and 12 volt high power cable that I think is important for you guys, because there are some nuances that we're discovering even more than I'm seeing people really talk about. And obviously, since I just went through the whole journey of learning how to desolder and resolder the connector on the 5090s, I want to prevent it from happening again. I don't want to be able to repair it when it happens. I want to prevent it and hopefully help prevent it happening to you. Today's video is sponsored by Thermal Grizzly, and if you're building a custom loop, you need to check out DeltaMate, their first complete lineup of custom water cooling hardware. DeltaMate is built for uncompromising thermal performance, but what really makes it different is how much it simplifies the whole process through modularity and precision manufacturing. And instead of needing a mountain of random fittings to finish one loop, DeltaMate uses just 9 modular SKUs to create over 20 traditional configurations, so you get way more flexibility with way less hassle. Everything has a consistent outer diameter, installs cleanly with an 8mm hex key, and even includes rotatable aesthetic covers so you can keep the build looking perfect no matter how your tubing routes. And whether you're running soft or hard tubing, DeltaMate supports multiple sizes including 16mm, plus newly added 14mm hard tube and 13mm soft tube. It also comes in black and matte nickel, so it'll match pretty much any build theme. Check out Thermal Grizzly DeltaMate at the link below. So what I have on both of these test benches right here are the repaired Astral cards that I worked on. And you'll notice here that we have these cables that are marked in orange, because what we've identified is do you remember how I was like, oh man, I'm not getting the perfect pin distribution that I wanted? And I thought, well, maybe that's just the nuances of the card, right? Now that would be interesting for the Astral, because the Astral has individual power planes for each of the 6 12 volt pins that come in on the 12 volt connector. Now, just for sanity purposes, we threw that brand new Tough card on the bench over here and saw big pin variance as well. Enough pin variance to where the WireView 2 was actually warning us that it was exceeding 10 amps and was gonna go into shutdown. Now, that's brand new out of the box, and I find it very difficult to believe that that would be the way that the Tough is designed. Like, I'm sorry, no 5090 out of the box should be pulling up 10 plus amps per pin at stock, right? Stock is 600 watts, but still, that shouldn't be happening. So I started doing some deep dive and started playing around with different cables and started experiencing some things that really show that the problem is not even necessarily the connector in our case, well, in some of them anyways, but what appears to be potential wearing out of the wires themselves somewhere in the sleeving. Let me explain what happened. This particular cable right here, at least we think it's this one, it could potentially be this one, they're identical. These are some Amazon cables that I got over a year ago, well, about a year ago when the 5090 first came out. And let me just be fully transparent. These cables get cycled way more than any average consumer would, because we have seen probably 100 different iterations and card installs or more go through our test benches when we're doing all the benchmarks, when we're retesting things, when we're unplugging the cable and plugging in a new card. Like, it is very unrealistic as to what these cables go through versus an average consumer. But just the other day, this cable was plugged into the card, and then this was plugged into the PMD, because we're running the Corsair power supplies, although I did switch this one to an MSI 1250 because I wanted native 12 volt on each end, just to rule out whether or not part of what we were dealing with is the Corsair terminating to 2 8-pin type 4s, which should not honestly be a problem. I don't think you really need to have 4 PCI Express tying in, because they're all gonna just terminate down to 1 wire anyway. So this is just a single wire lead all the way across. If the 12 volt high power on each end can carry enough current per wire, then this should be fine too. Anyway, I digress. What I noticed was, and Phil was watching this happen, this was plugged into the card and this was plugged into the PMD. Didn't touch either end. I touched the middle of the cable and did that, and then the card shut down. That told me there's a weak wire somewhere in this harness. Now, because of how many times it's been plugged in and flopped over and plugged back in and flopped over out of the way and pushed out of the way, and the rig moved and dangling and all that, who knows what kind of stress has been put on this. Now, this is a pretty heavy braided cable. And what I mean by that is like the sleeving on here is very thick, actually. So we don't even actually know how thin or what gauge wire this is in here. It tells me this cable is worn out, but not because of the plug end. In fact, we were getting some pretty major swings. If I didn't record it, and I really should have, but when I plugged it in, the same card over here, because we would go from this rig to this rig back and forth just to measure the pin variance under load to see whether or not we were dealing with the card or dealing with the cable. Because I was getting ready to put the cards under the iron again to reflow those holes, thinking maybe I didn't get solid connection through all layers of the board, which could potentially, if I was getting the same pin always having a low amp draw through it, then that would be an indicative of, okay, we've moved it to different rigs, we put it on different cables, the same pin is problematic, that could tell me it was potentially my problem. But what we started noticing was by changing the cable or unplugging it, plugging it back in, or even moving it to a different rig, the low pin was changing, it was moving around. It's like, okay, that's not a physical problem with the card itself, that's something between the card and the power delivery system that was causing the problem. And the only thing there is the cable. Now, just before starting this video, I looked over at this cable and went, that's a shiny spot. The corner pin on this Corsair cable has pushed out. That is not the first one we've had that happen to. In fact, you can see just how loose that pin is. So it's almost like the barbs that hook into the plastic have either become bent or in some way. And so there's a lot of play there. So what happens is you plug the card in and it pushes that pin back out. Now that particular pin right there is a ground pin, which now means if it's not making solid connection, the other wires have to carry remember, power has to have a positive and a negative if we're talking about DC or direct current, right? So that means if we have 6 12-volt pins bringing power in and we only have 5 of those ground wires, going negative and returning that power to the power supply, now we're putting more amp draw on the return side or the ground side than we would want, and that could potentially lead to burning up that particular cable. In fact, the longer I let that sit here right now, that's a bit of a problem. But here's the crazy part. If we look at the screen right here, even just an idle, I would expect it to be potentially a pin 6 or something showing the low power, but it's actually pin 5 right now showing low power at 0.28 amps at idle. So I wanna just kind of see if I can push this in real quick and see if we get any. Yeah, well, as you can see, the whole card just shut down by me touching it. So either one of two things are happening here. And it's probably gonna go full speed now? No. Okay. No, that's a ground pin. So that has to mean there's individual ground sensing. I've had people argue with me that the Astral still has a unified ground plane. But if that were the case right now, having that one ground wire not touch or make poor contact, why would it shut down the card? Because it should still have all the other 5 ground pins carrying the signal. In fact, it kind of is a unified ground plane, because you can even see in the pad of the PCB when I was doing my soldering, it's a solid ground, just a big chunk of ground coming to it. So it's still weird to me that happened. Now, I'm gonna pull this pin out entirely right now. With zero effort, it just came right out. I wanna see now, will the card turn on with that missing? I'm curious as to why I can boot the card without it touching, but having it make maybe poor solid contact for a moment was enough to shut down the card. Obviously, that's pretty extreme right there. Now, we know that this can work like this because remember, Der Bauer, when he was doing some of his testing, actually, I think he was using a non-Astral, because with an Astral this wouldn't work, but he was like removing or cutting wires to where he only had 2 wires drawing or pulling power into the graphics card, and then he showed how even those 2 wires didn't melt. Now, obviously it's not recommended to do that, but so that cable is clearly bad. Let's get this cable out of here real quick and see if I can put in one of my other funky cables to show you some of the crazy pin distribution. Now, just to put this into perspective right now, this has been running for Mark behind me right now, right? This has a brand new Cable Mod RT. This is a right angle connector. This is not like the ones that were recalled, by the way. That's his adapter. It's totally different. And this is 12-volt high power, not even 2x6. We've had these for like 2 or 3 years sitting in the box. So I need some new cables right now to sanity check. So what I have right now is a brand new cable coming out of the MAG power supply from MSI into my PMD, and then the right angle cable coming out of my PMD into the graphics card, and look at my power distribution. This is the card that I was getting ready to resolder. But under load right now, it says 610 watts coming through the cable. PMD is actually reporting 644 average watts right now. Remember, we know that due to efficiency loss, it's going to pull more through the cable to supply the power that's needed after heat and efficiency loss. So that's normal. It's a little on the high side, but it's normal. 8.2, 8.2, 8.5, 8.6, 8.9, and 9.0 is the highest right there. And this has been running now for 18 minutes and 38 seconds under load. So that's better than what I was getting when I initially showed you guys, look, I did it, I fixed it. And I guess I did fix it, because I thought maybe I still sucked and something was wrong, and that's why we weren't getting it to, that's why we weren't able to get it to do what I needed in terms of even distribution. So I was getting ready to resolder it, which is totally unnecessary. Now this is a brand new one, by the way. I want to point this out. That's why there's no orange on it. This one had been used quite a bit. This one that's got all the individual like wires that are separated like this is when we did our video about when we used the amp clamp meter on a regular 5090, which the Astral would have made that video a lot easier because of the individual pin sense. It would have been easier to log that. But we used the clamp meter to actually measure the current coming through this. So we know this cable has been cycled well over 100 times, because we did 100 times in that video alone. So I'm not gonna trust that cable anymore, but this is a brand new one right here. So I'm gonna plug this in and measure again to see what happens to our current. What I didn't show you, because that wire pulled out, was that I was getting some of the amp draw to be as high as 11 amps, which is certainly not within spec. And I don't like how easy that pushes in. Here's my problem too, is like in terms of fitment, I'll get it lined up. And look, it just takes like no effort to push that in. Here is the cable mod one. Ugh, that one takes a lot more force, which makes me a lot more comfortable. That Corsair cable is a brand new one. Now, we did a video where we talked about the Corsair cables, and we're not a fan of them for a few reasons. I don't think it's necessarily a problem that it goes to an 8-pin. It's probably safer to only have the 12 volt on one side if you want to know the truth. But what you just saw, this insertion force right here, and then the amount of movement and wiggle it has, I'm just not comfortable with that. 6.0, 9.1, 9.1, 8.9, 9.1, 8.0. See, now we're already hitting some red numbers. It's doing worse than the busted cable. Now, it's pretty obvious that because of the loose fitting nature of that cable, that the loose fitting pins are not able to carry as much amps as the tight fitting pins. So power is a fluid, essentially. Electricity is like a fluid. It wants to travel to the path of least resistance, which means it's gonna want to prefer the pins that are carrying the most contact surface, or surface area, if you will. So, because the better pins are able to carry more amps, we have pin 1 doing very light lifting at 6.2 amps. And then we have pin 6, which is the other outside end, a little bit less than the rest, but again, the middle pins are carrying the bulk of it. Here's the one next to us right here, for reference, that is doing exactly what we should be doing, and it just turned off. Let's do this now, because let me tell you what I do have. That's so loose. This is not a cable mod ad, I swear, but I do have native cables that are intended to go from Corsair to 12 volt high power. And they're actually 3. They have 3 plugs on it. So I'm gonna plug that bad boy in, get that going to the PMD, and then we'll show how just changing that cable is gonna change the behavior of everything you're seeing right now. But that card's shutting down right now. It's both a bad thing and a good thing. Okay, so this is a CSR cable from CableMod. Once again, CableMod is not sponsoring this video. They don't even know I'm making this video. It's just what we have on hand. This is their more basic cable. It does terminate to just 2 8-pin PCI Express. And this is like their Pro version, which has the 90-degree cable. This one terminates to 3. But to keep it kind of in parity, to make sure that we are doing A-B comparison here, is I'm gonna go direct to the graphics card first. And let's check insertion force. Oh my gosh. Ugh. You can see it, you can hear the crunch. It was like, so that's got a nice tight fit. Now I wanna see what we've got with just changing that cable out. Already at idle, 0.40, 0.38, 0.38, 0.36, 0.34, 0.34. But look at the power distribution now. A4, 81, 81, 87, A4, 83. Even if the cable is new, you can't trust, and look at the bend that this is kind of getting on there. It's a lot softer of a cable, right? So that's a pretty, I mean, it's not hurting it in any way, but look at that. That is really good, solid pin distribution right there. All right, what we're gonna do now is I'm gonna plug that into the PMD, and then I'm gonna show you another example of bad cables, because now I've got, like I said, these long-term use ones that I've been running for our test benches, which are definitely worn out. Ironically now, we're showing really solid pin distribution. Not really, yeah. See how pin 2 is down at 7.2, pin 5 and 6 are carrying most of the load at almost 10 amps. That's at 6.8, right? So that good cable you just saw me use is now plugged into the PMD. The PMD has a unified 12 volt and ground distribution, so it's not per pin. So that means essentially this is now like the power supply, like as if this was attached to the 12 volt rail in the power supply, which means now any variance we're seeing is specifically with this cable. Now look at that, it's, pin 2 is dropping. It was down in the 5s for a second there, which means the other pins are having to carry more of the load. So that one's at 10.1, 9.3, 9.4. I wanna see now if this is the one that if I wiggled just right, it turned off. There we go, look at that, where it's resting now. 5.6. So yeah, there's a prime example of a cable, let me shut this down, of a cable that looks perfectly fine on the connector ends, which is really the only way people are kind of evaluating whether or not their cables look worn out or not. Yeah, if you look on both ends, like nothing looks out of place. They all sticking out, nothing's pulled back. Clearly something is wrong with this cable. Now even just idle this distribution, right, with these fresh cables, they all in the midpoint 3s, exactly where it should be, under load. It's perfect. I mean, one could probably argue pin 1 slightly low, but I mean, we're talking the widest variance between the lowest and highest pin is 0.7 of an amp, which is perfectly normal. I mean, this one over here has almost the same swing, right? 8.26 to 8.94. That's perfectly normal. So what I was about to do was put these cards under the iron again unnecessarily. And it really was Phil that saved me from that, because he was like, dude, I think you're chasing a cable problem, not a card problem. And I was like, why do you say that? He goes, because if it was a card or a solder problem, you would have consistency on the pins that's acting weird. You wouldn't have it move around. It's not like the solder joint's jumping around, you know? So anyway, this is now exactly what we expect to see. This is comfortable, nothing's in the red, temperatures are great, right? Everything's right with this. This has been running for 42 minutes and this is how the distribution is with the exact same setup. Only it's a different power supply, but from the PMD to the card is the exact same cable and stuff. Now you might be asking yourself, Jay, I don't have an Astral. I can't do per pin monitoring. Now you might be thinking to yourself, oh, it doesn't matter. I'm running a 4070 or I'm running a 5070. It doesn't pull that kind of power. Low wattage cards have also melted themselves because if you start getting to a scenario where pins are or the wire and the pin is operating outside of its spec, then this can happen to anyone. We've seen 5080s and 4080s melt cables. We've seen 5070s melt cables. We've seen 9070 XT Sapphire cards that run this same connector melt the cable at half the wattages that a 5090 pulls. So don't think that you're immune from this because you just don't have a ridiculously overpriced and overhyped 5090. This is where the wire view comes in. Again, not a sponsor. I know this just sounds like QVC for all the shit you should be buying today, but it's not. It's just, this is the formula I've stumbled across that's like the safest for us. This allows you to do per pin monitoring on cards that do not have it built in. So the only cards that have it built in right now, as far as I know, is the Astral and the Matrix. I don't know if the Galax Lab OCs or the MSI Lightning has it. I would assume they probably do. It seems like a really good thing to start building in. But the wire view, it's $170. It's not cheap. But what's better? A $170 device that will shut down your card for you if something is wrong, or replacing the card, or even mailing it into someone to have it repaired? Because I can promise you the repair is going to cost you more than that. The bench fee alone for most repair shops is $125 before repair. So I would honestly recommend this. I think it's back ordered for a bit, but this is like truly insurance for your investment, which any graphics card tier this day is an investment. So these are all junk. You might be asking yourself, Jay, what cables are they? And please let me preface this with the exception of the brand new Corsair one that's doing what you guys saw. These cables have been put through the paces. They have definitely done more heavy lifting than any consumer cable would. But these guys right here, these were easy DIY from Amazon. Got a solid year's use out of them before getting to the point to where we were uncomfortable with the pin variants. Obviously, the Corsair cables that come with the ATX 3.1 and 3.0 power supplies, and then Cable Mod Stealth Sense cable. That's what we're using. So hang on to this guy, this actually works. In fact, this is the one, like I said, that shows that has 3 8-pins that connect directly to the Corsair power supply. You can get them either a 12-volt high power or 2x6, or 2x6 now, on both ends if you want, or you can get them direct to your power supply manufacturer. If you feel like, I honestly think this is the way to go for your particular power supply, rather than going 12-volt high power on both ends, because it really reduces the potential of the connector issue to 50% failure rate, because now you're only dealing with 1 instead of 2. So you can get these, you can get them that have matching ends for Corsair, Cooler Master, Asus, Seasonic, Fantex. Because remember, there's only like 3 ODMs in the world really for high-end and even regular PC power supplies. So you just go to their website, tell them what you have, and they'll give you the number, and then you can even just buy it off Amazon if you want. They come next day for most people, and they're about 29 bucks for the cable. But I would go with the PCI Express, the standard power end. That way you only have one 12-volt to worry about. There you go. Your cable might look fine. The connectors might not look like they have loose pins or anything, but you could have a problem in the middle of the strand, as I just demonstrated. Hope this helps somebody and stops someone maybe from melting their shit and it's not too late. Thanks for watching, guys, and we'll see you in the next one.